Here's a study guide for Chapter 5, and we're going to go through and discuss the chemical reactions and what is in a chemical reaction, the parts of a chemical reaction. Then down below here, we're going to be doing some balancing of equations, and then we're going through the 5 classic chemical reactions and what to look for, how to describe them, and the identifying features for the 5 classic reactions. We're going to talk about how a reaction behaves with its dynamics, and we're also concluding with the separation techniques. So this is the review for Chapter 5. So every chemical reaction has to have something that it's starting with and something that it becomes. What it's starting with is called the reactants. So if we can just say that this is going to be my capital R for reactants for a symbol, and they become the products, capital P down here. So your reactants, these are your starting chemicals in a reaction. It's the things that are reacting. Starting chemicals in a reaction. Again, if you are participating in an event like in a marathon, you are a participant. The things that are reacting, your starting chemicals are the things that are reacting, so they are called reactants. And they become the products. This is going to be the ending chemicals in a reaction. The ending chemicals in a reaction. All chemical formulas also have this arrow symbol, and it starts off with reactants or reactant, and you see this arrow leading off to the right towards the products. And the arrow, what that means, this arrow means it either becomes or it produces, or some people would even say it yields. So the reactants become the products. The reactants produce the products. The reactants yield the products in a chemical reaction. In a chemical reaction, we have these things that are called subscripts. This is the little number below. For example, if you have water, H2O, the subscript is the number that's below, H2. And what this tells you, this is the number of atoms in that substance. So water is composed up of 2 hydrogens and 1 oxygen. Coefficients are the big number in the front. So if you have 2 waters, you have 2 H2Os. So it's going to be the number in the front. What does this tell you? This tells you not the number of atoms, this tells you the number of molecules. Number of molecules of that substance. So the subscript is within the molecule, and it tells you how many atoms of that element that you have. The number in the front tells you the number of molecules of water that you would have. So these are the characteristics of chemical reactions. Here are 2 chemical reactions, and you can see we have our reactants and our products. Reactants in the products, we also have the arrows which indicate a chemical reaction is taking place, and we also have subscripts, but you'll notice that it's lacking in coefficients. These are not balanced reactions. We're going to be using coefficients. So to balance things, we need to use the coefficients, and to remind you, you are not able to use subscripts to balance things, because if you use subscripts, that means you're changing the number of atoms in that substance, and so you're changing the chemical nature of it. For example, H2O is very different than H2O2. So if you're balancing waters or oxygens, you can't just put a 2 down below here because you're now changing the substance from H2O to H2O2, which is a different material. So let's go ahead and balance this. And we're going to be using the counting method. If you're familiar with it, you're welcome to use the mental method on the exam, because I won't be able to tell the difference. But for this, we're going to go over the counting method. And to do this, if you remember, you list your number of each of the elements. So you have your iron, and you have your oxygen, and you have your iron and your oxygen. So I'm going to start over here. Here I have 1 iron, and I have 2 oxygens. On the other side, I have 2 irons, and I have how many oxygens? 3. So we're first going to start by saying, well, I can see that I have 1 and 2, and those are not balancing out. So let's try doubling this, and I'm going to make this into a 2. So I'm going to multiply this by 2. So I'm going to put a 2 in front of the iron right here, and now I have 2 of my irons here and 2 irons here. But unfortunately, my oxygens are not balanced. So what am I going to have to do to balance these? Well, notice you have a 2 and a 3. What's going to be the common, lowest common multiple of 2 and 3? It's going to be 6. So I'm going to have to multiply the oxygens on the left-hand side by a 3. So I'll put that 3 there. We're going to multiply the right-hand side by 2. So that's going to give me 6 here. It will give me 6 there as well. So let's go ahead and multiply the oxygens over here. I'm going to be using coefficients, so I'm going to be putting a 2 right there. So now let's see if this is now balanced. So in doing so, by adding 2 times 3, that gave me the 6 oxygens, but it also changed the number of irons that I have. How many irons do I now have? I have 2 times 2, which is equal to 4. What am I have to do over here? I'm going to have to multiply this by 2 again to get this to be 4. So that 2 will cross off, and we're going to replace it with a 4. Let's double check. I have 4 irons here. 2 times 2 gives me 4 irons there. For my oxygens, I have 3 times 2 gives me 6. Here I have 2 times 3. It gives me 6. So now it is balanced. Go ahead and try to do this by yourself, and I'm going to, hopefully you can pause and then come back when you've tried it. Okay, hopefully you've done this and you've listed them, the P, O, and H, and the P, O, and the H. So how many of each? I have 4 phosphoruses here, and I have 1 phosphorus there. Here, this is kind of strange, I have 10, and then I have 11 phosphoruses. 11 oxygens. And on the other side, I have 4. This is going to be really hard to balance because I have oxygen that's in both of those molecules. So we'll try to balance that one last. Hydrogens, I have 2 over here, and I have 3 over here. Let's start with the phosphoruses. I have 4 over here, and I need to have 4 over here, so I multiply this by 4. So let's put a 4 in the front right here. This 4 also gives me 4 times 3, or 12 hydrogens. And it also gives me 4 times 4, which is 16 oxygens. So not only does it give me 4 phosphoruses, I get 4 times 3 or 12, 4 times 4 is 16. So now I need to make these molecules appear to be the same on both sides. So my phosphoruses appear balanced. I have 4 here and I have 4 there. Okay, we're going to do this one last. Let's take a look at this. What am I going to have to do for this to get it to be 12? I'm going to multiply it by 6. So if I multiply this by 6, I'm going to put a 6 in there. This gives me 6 times 2 hydrogens, which gives me 12. But it also gives me 6 times 1 oxygens. But if you remember, 6 times 1 gives me 6, but I also have the oxygens over here. I have 6 oxygens here, and over here I have 10 oxygens. 10 plus 6 gives me my 16. So that's going to balance that side. On to the next page, the 5 classic chemical reactions. So the first one is going to be a synthesis reaction. It's also called a combination reaction. Combination reaction. This is when things are going to combine with each other. This is when 2 or more things become 1. For example, you can take hydrogen and oxygen. The 2 things come together to become 1. You take smaller molecules and you combine them to make a larger molecule. Decomposition, things that are decomposing. Things that decomposing are breaking down. A decomposition is the opposite of a synthesis reaction. This is when one larger thing is going to break down into 2 or more things. If you start off with hydrogen peroxide, this will naturally break down into water and oxygen. So you start with 1 compound and you end up with 2 or more. So single replacement reaction, what you should be looking for with this is a single element. A single element. We took magnesium in lecture and we dropped it into hydrochloric acid. And the magnesium started fizzing, and it produced hydrogen and magnesium chloride, or MgCl2. What happens is, this is the single element. This single element is going to be kicking out this, and it's going to be producing the hydrogen. So look for the single element to replace one other element in the other compound. Double replacement, what you're going to be looking for are 2 compounds. A double replacement is very similar to a single replacement, but you're not starting off with a single element. You're starting off with 2 compounds. For example, if you have calcium chloride, CaCl2, and this substance called sodium carbonate. In the double replacement, what's going to happen is, notice how I don't have a single element like I have the magnesium all by itself. I have 2 compounds that consist of at least 2 elements each. What's going to happen is that these are going to be switching places with each other, and we're going to be creating, if the Ca comes over here and kicks out the Na, I create CaCO3. And if the Na comes in to kick out the Ca, I form NaCl. Combustion, the key to look for in combustion is it requires oxygen as a reactant. So like the candle needs oxygen in order to burn. So do all combustion reactions. The combustion in your engine needs oxygen. We burned methane, which is just the natural gas here in our room. And when you combine this with oxygen, typically the end products of a combustion reaction are going to be carbon dioxide and water. Okay, the dynamics of reactions. We have exothermic and endothermic. Exo, exit. In exothermic reactions, heat is going to be exiting. So heat is going to exit the reaction. And if heat is exiting the reaction, it's coming out of the reaction, it's going to feel hot. Endo means in, So heat goes in the reaction. So the surrounding heat is going to go into the reaction. So your test tube or container will feel cold. We looked at the rate of reaction and the temperature. When you increase the temperature, this causes molecules to speed up. So what's going to happen is you're going to increase the speed of the reaction. If you remember, with the Alka-Seltzer, the hot reacted much faster than the cold. So if it increases the speed, it's going to decrease the amount of time it takes to complete the reaction. And vice versa. If you decrease the temperature and you have it colder, the colder Alka-Seltzer decreased the speed of the reaction, and it increased the amount of time. It took longer for it to take place. And the rate of reaction with the size of the particles. If you remember, we crushed them up. If you increase the size, the normal Alka-Seltzer took about a minute. Okay? It was a very slow reaction. It decreases the speed of reaction, and it increases the amount of time. If we crushed it, we decrease the size. So here it's going to be crushed. If you you decrease the size, you crush it, it increased the speed of reaction. This took place in just about 10 seconds, and therefore the time, the amount it took was lower, and it went faster. We also have these 3 separation techniques that we looked at most recently. We have chromatography, distillation, and filtration. Chromatography, what this does is this separates dissolved solids. And if you remember, this was the colors that we used, or the pigments. And the factors that affect the rate of motion or the movement of those molecules deals with how well it dissolves and what's called the adsorption. So if you remember, adsorption is sticking to. So if you increase the adsorption, this is when those particles are sticking to the filter paper. So it's going to stick to the paper. If it's going to stick to the paper, it's not going to move very much, and therefore it's going to decrease the amount it moves. It's going to decrease the distance. If you decrease the adsorption, it's not going to stick to the paper, and it's going to move a lot more, being pushed by the liquid. And the other factor that will affect how well it moves on your paper is how well it dissolves. If you remember the Sharpie marker, as well as the whiteboard markers, those did not dissolve. Therefore, they didn't move. Only the Crayola ones that dissolved in the water, those were able to move. Now, distillation was a process that is used to separate 2 liquids or multiple liquids. So we can separate liquids by boiling. So we're going to be heating them. And then, if you remember, we had this distillation apparatus had what's called the condensation tube. And then condensing in that condensation tube. So you heat and then cool. The third one is filtration. This is going to separate solids and liquids. So the first one separates 2 dissolved solids. The second one separates 2 liquids. The third one separates a solid from a liquid using filter paper and some type of funnel apparatus. That's it.